As I was mentioning, one of the new trends in the fiber to the antenna is to actually do field termination of fiber optic cables. This turns out to be very much in keeping with the historic methods of deploying coax-based systems. If you go back, when tower hands were deploying coax-based transmission systems, they would roll out a spool of coax and they would crimp on a connector to length, thereby exactly matching the cable length with the size of the tower. As the industry began to evolve towards fiber-fed systems, the initial response was to use factory terminated or pre-terminated fiber optic connectors. And that was primarily due to a lack of familiarity with the characteristics of fiber optic cables. However, recent developments have shown interest in doing field termination of fiber optic cables, thereby eliminating the two worrisome issues of excess slack storage or, more importantly, cables that are too short. 3M offers a number of products in this solution space. They're featured here on this display. We have our NPC series, or no polish connector, that feature a pre-polished ferrule with a short stub of fiber inside with index matching gel and a mechanical splice element. We also have our Crimp-Lock Plus connectors, which have no internal splice, but they do have an innovative polishing mechanism that's easy to perform in the field, and it's very simple to operate. So my colleague here will demonstrate how quick and easy it is to perform a fiber optic splice with the NPC LC mechanical splice in the field. As you can see, when the fiber bows, the splice has reached the adequate tension, the splice is actuated, and then the buffer clamp is then engaged to basically hold the fiber jacketing in place, achieving approximately a 4-pound pull-out rate, which is significant for this type of mechanical splice. So what we're actually seeing is that with these very simple, low-cost tools and a simple cleaver, that you can actually affect fiber optic splice in low fiber counts. Typically, the types used on a cable might be 12 fiber cable, 24 fiber cable. You can achieve these once you've had a little bit of practice in maybe 2 minutes per splice, thereby eliminating the extra cost and overhead of having pre-terminated cable assemblies of multiple different lengths and, more importantly, the wrong length. So this is an important development in this space, and we're very excited about the possibility for it to enhance and speed up the deployments of LTE infrastructure.